Ever stared at a home renovation show and wondered how they even begin to guess the cost?
Oh, yeah.
Or, maybe more importantly, how accurate those guesses actually turn out to be?
Right. We all do a little bit of that mental math, don't we? Just estimating things day to day.
Exactly. But today we're really diving into the nitty-gritty, how the pros handle this in the, well, often unpredictable world of construction.
Yeah, exactly. Think of an estimate as let's say, a highly informed prediction.
Okay.
It's built on the best available information you have at that specific moment, usually focusing on, what something will cost or maybe how long it'll take.
Right. Like estimating your drive to the store versus estimating a skyscraper.
Precisely. That casual guess is one thing, but in construction, these projections, these estimates, they're absolutely vital for everyone involved, from the person dreaming up the project right down to the team actually building it.
Okay. So for this deep dive, we got some really insightful material here.
Hmm.
Our mission is basically to pull back the curtain on construction estimating. We really want to understand why it's such a fundamental piece of the puzzle and explore the different kinds of estimates that get used, sort of demystify that big number, the total project cost.
And hopefully by the end of our chat, you'll have a much clearer picture of all the layers, all the things that feed into that final price tag.
Right.
It's really about looking beyond just one figure and seeing the tons of considerations that get factored in. And this kind of framework, it gives you a really valuable perspective, honestly, whether you're thinking about a huge building project or you're just curious how it all works.
And just so everyone knows, we're building this on solid ground. We're drawing from some foundational text on construction estimating principles.
Good stuff.
Okay, so let's jump right in. Why? Why is estimating just so incredibly important in construction?
We'll start with the owner. For them, it's really about connecting their vision with, financial reality.
Uh-huh. Can they afford the dream?
Pretty much. They need to figure out how to balance what they want, their goals, against what they can realistically afford. So those early estimates, they're crucial. Setting a budget, figuring out if the whole project is even feasible,
Right.
making big decisions about size, scope, the level of quality they can aim for. It even lets them compare different ways they might approach the project.
So it's strategic for the owner.
Definitely strategic. Can we afford this whole dream? That's their question. Whereas the contractor's estimate, that's more tactical.
How so?
Theirs is about, okay, what's it actually going to take to build this specific thing? Understanding that difference is really key to keeping everyone on the same page.
That's a great distinction. You wouldn't want to fall in love with some amazing design only to find out later it's like double your budget.
Exactly. Nightmare scenario.
So what about the designers, the architects, the engineers drawing everything up? What role do estimates play for them?
For the design team, estimates are, they're kind of like guardrails and a guide. They have to make all these design choices, specific materials, how complex the building systems are, but they have to do it all while keeping the owner's budget firmly in mind. The estimate becomes this, constant feedback loop during the design process.
Okay. And then the folks actually putting hammer to nail, the contractors.
For contractors, the estimate is, it's the absolute foundation of their business, is how they figure out their bid price.
The number they give the owner.
Exactly. The amount they propose, the owner will pay to get the work done. And accuracy here is just paramount.
High stakes, you mean?
Absolutely. If their bid's too high, they probably won't get the job. Someone else will undercut them.
And if it's too low?
Well, then they risk making no profit, or worse, actually losing money on the project.
Wow. Yeah, talk about high stakes. It sounds like getting that estimate wrong can cause major problems for everybody.
Oh, absolutely. The fallout can be huge. Bad estimates lead to budget blowouts, arguments, delays. Worst case, the whole project can collapse. It's a really serious part of the business.
And it's not just like a one-and-done thing at the start, right? The source mentioned estimates happen throughout the project.
That's a key point. It's definitely an ongoing process, not just a single event.
So when does it start?
Right at the very beginning, the initial feasibility stage, when the project is maybe just an idea on paper.
Yeah.
Then, as the design gets more detailed, the estimates get updated, refined continuously. You do estimates before you even pick a contractor, and you definitely need them during construction if things change or you hit unexpected problems.
So that first quick guess, maybe scribbled down, is going to be way different from the super detailed breakdown later on.
Totally different. Those early estimates, they're much faster to produce because, well, there isn't much detail yet.
Right.
But that speed, it comes at the cost of accuracy. As the project moves along, as you get more drawings, more specifications, the estimates become way more detailed, more comprehensive, and crucially, much more reliable.
Okay, so we get why we estimate and when it happens. Now, the materials stress this important difference between the owner's estimate and the contractor's estimate. Let's unpack that a bit.
Yeah, this is really critical to grasp. The owner's view of project costs, it's much, much broader.
Broader how?
They're thinking about the total financial commitment for the whole thing.
Yeah.
From the very first spark of an idea all the way through design, construction, getting the building occupied, maybe even operating costs down the line.
So it's way more than just a brick and mortar cost.
Oh, absolutely. It includes stuff like, well, buying the land itself, all the fees for the architects and engineers doing the design work, maybe costs for marketing or sales teams, legal fees, accounting costs, even the interest paid on loans to finance the project.
Wow.
The actual construction cost is just one slice, albeit a big one, of their total financial picture.
So when an owner looks at an early estimate, they're using it to answer those really big strategic questions. Like, can we actually afford this whole venture? Should we think bigger, smaller? What level of quality, what finishes can we realistically hit within this budget?
Precisely. Their estimates are the main tools for making those fundamental calls on affordability, size, overall quality. Now, the contractor, their focus is much narrower.
Really? But they're the ones doing the building.
They are, yeah, but their estimate usually zeroes in very specifically on the costs for the piece of the project they've been hired to do.
Okay.
So that mainly means the direct costs, the labor they'll use, all the materials needed, the equipment they'll need on site, and the cost of their own people supervising and managing the construction work itself.
Got it. So the contractor's estimate is laser focused on the tangible stuff, what it takes for them to physically build what's in the plans, and this number becomes their bid, right? The price they give the owner.
Exactly. It's their proposed price to deliver that specific construction work. Okay, so as a project goes from just a concept to, detailed plans, the types of estimates used also get more and more detailed.
Right. The material laid out a few distinct types. Let's start at the beginning, those really early ones. Conceptual estimates.
Conceptual estimate. Yeah, sometimes people call them rough order of magnitude or ROM estimates or feasibility estimates. They're really where it all starts.
When the design is still pretty fuzzy.
Very fuzzy, often before there are even any proper drawings.
So how on earth do you estimate a cost then?
Well, you lean heavily on history. Cost data from similar projects built in the past.
Okay.
A common way is using what's called gross service unit pricing. Think of it like this. For a hotel, maybe it's a cost per guest room. For a school, maybe cost per student. Hospital, cost per bed, that kind of thing.
I get it. So if you're planning, say, a 100-room hotel, you'd look at what similar hotels recently cost per room to build, roughly. It's a very broad stroke.
Yeah. Very broad. Exactly. These are used in those super early talks just to see if the project is even in the right financial ballpark.
Right.
And because they're based on past projects, you usually have to tweak them. Adjust for the specific location of the new project, adjust for any inflation since those other projects were built.
Makes sense.
But they typically don't include costs for really unusual design stuff, or the land itself, or design fees, or financing costs. It's a simplified picture.
So a ballpark figure just to check basic viability.
Yeah.
Got it. What happens next as the design starts taking shape a bit more?
That's when you move into design estimates. These get developed once some key design parameters are known, but crucially, while design decisions are still being made.
So they're more detailed than the conceptual ones.
Definitely more detailed, more accurate, and they become really vital tools for both the owner and the architect to kind of steer the design process and keep things on budget.
And the material mentioned a couple of approaches here. Square foot estimating was one.
Square foot estimating, yeah, it's pretty much what it sounds like. You project the total cost based on the building's overall square footage.
Cost per square foot times the total area.
Exactly. It's similar to the ROM idea, but the cost data you use is generally a bit more refined. Instead of just cost per room, you might have a more specific cost per square foot for, say, office buildings versus warehouses versus retail space.
Okay. So you have different square foot costs depending on the building type.
Precisely. It allows for a bit more nuance as the basic size and function get clearer. Then you can get even more detailed with something called assemblies estimating.
Assemblies estimating.
Okay.
What's that?
So building on square footage, assemblies estimating dives deeper. Instead of just the overall area, you start looking at the cost of individual building systems or components.
Systems, like the foundation is one system, the roof is another.
Exactly. The foundation is an assembly. The whole exterior wall system is an assembly. The structural frame, the mechanical systems like HVAC, electrical, each major component group is treated as an assembly.
So you're estimating the cost for each of those big chunks separately, not just a flat rate for the whole building.
That's the idea. You analyze and estimate the cost for each of these major systems. It requires a better understanding of how they go together, what parts are involved, and having cost data broken down by assembly lets the design team make much more informed comparisons. They could look at the cost difference between, say, a brick exterior versus a metal panel exterior, or compare two different types of HVAC systems.
Sounds like that gives you a much clearer view of where the money's going and makes it easier to make targeted cuts if you need to save money.
That's a huge advantage, yes. Now, once the design is basically locked in, or very close to it, we get to the most detailed level. The detailed estimate.
Okay, and these are the ones the contractors put together when they're bidding, right? When they have the full set of drawings and specs.
Exactly. Also called final estimates or bid estimates or sometimes unit price estimates. They're developed by the contractors competing for the job, especially for what's called a lump sum contract, where they agree to do the whole scope of work for one fixed price.
So what goes into these super detailed estimates? It must be a ton of work.
It is. It involves meticulously calculating the cost well, pretty much every single thing needed for the construction.
Every nut and bolt.
Almost. It includes the price of all the labor, every single material from the concrete down in the ground to the final coat of paint, all the equipment needed on site, the costs of any work they plan to subcontract out to specialists.
Okay.
And then on top of all that, the contractor adds their overhead costs, the cost of running their business, plus any taxes, and of course their planned profit margin.
So this detailed estimate, this number, is what forms their official bid to the owner, their final price tag.
That's right. And like we said, the accuracy just keeps improving as you get more and more information, more detail throughout the project lifecycle. And it's always, always worth remembering. Making changes during the design phase, when you're working with those design estimates, it's way cheaper and way less stressful than finding out you're over budget after all the bids come in.
Oh, for sure. Moving lines on a drawing is a lot easier than moving actual walls.
You got it.
Absolutely.
Yeah.
Okay, now, the source material also went into a lot of the specific things, the factors, that can really push construction costs up or down. Let's explore some of those. Project size and complexity seems like an obvious one.
It does seem obvious, right? Bigger project, more materials, more labor, so it costs more overall, and usually that's true. But sometimes larger projects can actually benefit from what we call economies of scale.
Okay, how does that work?
Well, think about it. Once a contractor gets their crew and all their big equipment set up on a large site, it can be more efficient to keep them working there steadily for a longer time rather than moving everything around constantly for smaller jobs.
Like buying in bulk is cheaper per item.
Kind of like that, yeah. And repetition helps too. If a worker is installing, say, thousands of the same ceiling tile, they tend to get into a rhythm, get faster and more efficient. So the labor cost per tile might actually go down.
Interesting. But complexity throws a wrench in that.
Oh yeah, big time. Anytime the design gets tricky, really high ceilings, weird angles, non-standard layouts, complex shapes, worker productivity tends to drop.
Takes longer.
Takes longer, needs more careful work, maybe more specialized skills. So labor costs go up. Simple, straightforward designs, generally much cheaper to build.
Makes total sense. What about the actual stuff going into the building? The quality of materials and performance goals? That must be a big cost driver.
Huge. It's logical, right? Higher quality materials, maybe custom windows, fancy marble floors, top-grade carpet that just cost more than the standard options.
Sure.
And if the project has specific performance targets, like hitting really tough energy efficiency standards or getting a green building certification like LED, those requirements add costs too. The project specs, the specifications document, that's where all those quality requirements are spelled out in detail.
So if you as the owner want the best, most sustainable materials, you got to expect a higher price. Okay, now location where the project is built, that seems like it would matter a lot too.
It matters in so many ways. First off, labor costs just very wildly depending on where you are
But
geographically.
wages are different everywhere.
Exactly. And site accessibility is huge. If your site is way up a mountain, just getting materials delivered is going to cost a lot more.
Mm.
Even how far the site is from the contractor's main office can increase their overhead for that specific job.
And it's not just about being remote, is it? Like, costs can vary even between nearby cities.
Oh, definitely. The source mentioned Boston versus Worcester, Massachusetts, not that far apart, but potentially different cost structures. A lot depends on the availability and cost of local skilled labor, local subcontractors. Do they have the right licenses? Enough experience?
So if there aren't enough local plumbers, say?
Then the contractor might have to bring plumbers in from further away, and that costs more. Even things you might not think about, like traffic in a busy city.
Yeah.
That adds costs. Just getting materials delivered, workers finding parking, maybe needing special permits or police details for deliveries. It all adds up, protecting the public around the site.
Wow, I never would have thought parking could actually impact the construction cost.
It all feeds in. The level of detail is pretty amazing.
It really is. Okay, what about the timeline? The schedule that has to matter.
Time is definitely money in construction. If you've got a super tight deadline, the contractor might have to accelerate the work.
Like pay overtime, bring in extra crews.
Exactly. Both of those drive up labor costs directly. But interestingly, a really long schedule can also increase costs.
How's that?
Mostly through those indirect costs we'll talk about later, like site supervision. The longer the super is on site, the more it costs. Plus, a longer project means more exposure to potential material price increases over time.
Risk factor.
Yep. And even the time of year matters. Building in winter might mean weather delays, needing temporary heat or protection, more costs.
So faster isn't always cheaper, but neither is slower necessarily. Tricky balance. What are the bigger picture, like the economy, market conditions?
Market forces have a huge impact. If the economy's slow, lots of contractors are hungry for work, competition gets fierce.
So bids might come in lower.
Yeah, they might sharpen their pencils, maybe trim their profit margin just to land the job and keep their crews busy.
And the opposite, busy times.
Opposite happens. If construction is booming, everyone's busy, maybe it's hard to even find enough skilled workers. Labor costs go up, and contractors can afford to be pickier, maybe bid higher because they have plenty of other options. Basic supply and demand.
Makes sense. Now, the source also mentioned something called management conditions. What's that about?
That relates to the, let's call it the human element and the process efficiency of the project team.
Okay.
If the owner is known to be really difficult to work with, for example, or if the architect is consistently slow getting answers back, or if the whole project just lacks good skilled management, that can all add cost.
Frustration.
Frustration, delays, rework. It all takes time and effort, which translates to cost. Even things like overly complex paperwork. Sometimes you see that on government jobs that adds administrative burden, which adds cost.
So a smooth-running project with good communication and clear processes isn't just less stressful, it's actually likely cheaper.
Generally, yes. A well-managed project tends to be more cost-effective. It's like a well-oiled machine versus one constantly grinding its gears.
Gotcha. And finally, the idea of special risks.
Yeah, construction is inherently risky. There are always unknowns. Those are the special risks.
Like what?
Really bad weather events you couldn't predict. Sudden, sharp spikes in the price of steel or lumber. Discovering unexpected things on site, like contaminated soil that needs remediation, or maybe undocumented utilities underground.
Stuff you couldn't plan for.
Exactly. So a good estimator tries to anticipate these potential risks. They think about the probability, how likely is it to happen, and the potential impact, how much could it cost if it does happen.
And how do they handle that in the estimate? Just guess.
Not guess, but manage the risk. They might use things like insurance policies, or they include a contingency allowance in the estimate.
Like a rainy day fund built into the budget.
Pretty much. A specific pot of money set aside just to cover unforeseen problems. It's about building in a financial cushion for those inevitable bumps in the road.
Okay, that covers a lot of what influences costs. Now, the material broke down the actual types of costs. Let's dig into those categories. Direct project costs. That sounds like the most obvious one.
It is the most direct, yeah. These are the costs tied right to the physical construction itself, the actual bits and pieces that become the finished building.
So concrete, steel, wood, windows.
Exactly. This category has 4 main parts: materials, labor, equipment, and subcontracts.
Okay. Materials are the physical items. Labor is the people doing the work. What's equipment again?
Equipment is everything from, power drills and saws up to the big stuff like excavators, cranes, bulldozers.
Right.
It can be the cost to rent that equipment, or if the contractor owns it, they'll charge an hourly or daily rate to the project to cover wear and tear, fuel, maintenance, that kind of thing.
And subcontracts, that's hiring specialists.
Yep. When the main general contractor, GC, hires out specific work like the electrical system or the plumbing to another specialized company, the total price that subcontractor quotes, which includes their labor, materials, equipment, overhead, profit, that whole amount becomes a direct project cost for the GC. The GC usually lists these separately and often adds their own markup.
Okay, let's look a bit closer at each of those. Materials. The source said the first step is figuring out quantities doing the takeoff.
Right. Doing the takeoff means meticulously going through all the construction drawings and literally measuring and counting everything.
Every single thing.
Pretty much. Every linear foot of pipe, every square foot of drywall, every cubic yard of concrete. You analyze every drawing sheet, identify all the materials, figure out the exact quantities.
That sounds intense.
It is, and the source noted they often do it in the sequence. The building gets built foundation first, then frame, then walls, etc., just to make sure nothing gets missed. An accurate takeoff is critical because so many other costs, especially labor, depend on those quantities.
Ah, right. If you miscount the drywall sheets, you'll also miscalculate the hours needed to hang them.
Exactly. And it's not just how much material, right? It's also what kind. The quality matters.
Okay.
The project specifications, the specs, they spell out the exact quality needed for everything. Is the drywall fire rated, water resistant? What thickness, what standards does it have to meet?
Gotcha.
So once you have the right quantity and the right quality for each material, you multiply the quantity by the unit price you get from your suppliers, and that gives you the total material cost.
Okay, materials seem, well, detailed but understandable. Labor cost, though that sounds like it could be trickier.
Generally, yes. Labor is usually more variable, more complex to estimate accurately than materials.
Why is that?
Because it depends on productivity. You calculate it by taking an hourly wage rate for each worker and multiplying it by their estimated productivity rate.
Productivity rate, like how much work they can do in an hour or a day.
Exactly. How many units of work, say, square feet of drywall installed or linear feet of pipe fitted, can an average worker get done in a set amount of time? And that hourly wage, it's not just their take-home pay.
Right, includes benefits, taxes.
Yep. Employer contributions for things like Social Security, unemployment tax, maybe workers' comp insurance, health insurance, pension contributions. All that gets bundled into the effective hourly rate.
And that productivity part, that must vary a lot.
Hugely. It depends on the worker's skill, their experience, obviously, but also the job site conditions. Is it well organized? Good supervision? Do they have the right tools ready? Is the work itself really complex? Are they working in bad weather? Even the scale matters. Installing a huge open area of flooring is usually faster per square foot than doing lots of small fiddly rooms with lots of cuts.
Makes sense. And then there are different types of wages, right? Prevailing wage, union, open shop.
Right. Prevailing wage, that's usually on government-funded projects required by laws like the Davis-Bacon Act. It sets a minimum wage, including benefits, based on what's typically paid for that trade in that specific local area.
Okay. To ensure fair wages on public work.
That's the idea. Then you have union rates, set by agreements between unions and employers, and open shop rates, which are negotiated individually between a non-union worker and the company. The estimator has to know exactly which rate applies to which workers on that specific project.
Wow. Yeah, keeping track of all that labor cost seems like a major challenge. What about equipment costs?
Like we touched on, it's either rented or owned. If rented, cost is just the rental fee. If owned, the contractor charges an internal rate to the project.
To cover.
Depreciation, repairs, fuel, maintenance, insurance for the machine, and sometimes the operator's wage is bundled in, sometimes it's tracked separately as labor. Depends on the company.
Okay. And then subcontractors again.
Right. When the GC hires, say, the electrical sub, the entire price quoted by that electrical sub covering their labor, materials, gear, overhead, profit becomes one line item, a direct cost in the GC's estimate, usually with the GC's own markup added on top.
Okay, so those are the direct costs, the stuff that physically makes the building. But there's another category, indirect project costs.
Yep. Also called general requirements or general conditions. These are costs needed for the project overall, but you can't really tie them to one specific construction task or one specific sub.
Like what? Give me some examples.
Okay, think about the GC's site superintendent, the main manager on site. Their salary is an indirect cost. Setting up and running the job site trailer or office, temporary utilities power, water for the site, scaffolding that multiple trades might use, general site cleanup, dumpster rentals, project meetings, maybe safety equipment used site-wide.
So it's the essential support structure for the project, but not part of the final building itself.
Exactly. The superintendent manages everything, coordinates all the subs, but you can't bill their time directly to installing Window X, and these costs are very time-dependent.
Right. Longer project means more weeks paying the super running the trailer.
Precisely. Longer project equals higher indirect costs. Simple relationship there.
Okay. And there was a third category, too. Indirect business costs.
Right. Usually just called overhead. These are the costs of just running the contracting business itself, not tied to any one specific job.
Like the main office rent.
Exactly. Rent, utilities for the main office, salaries for office staff, estimators, accountants, admin support not assigned to a single project, general business insurance, marketing, maybe software licenses, all that stuff.
The cost of keeping the lights on for the whole company.
You got it. And somehow, these costs have to be covered by the revenue from the projects the company actually builds.
How do they figure that out?
Contractors have different ways of allocating it, maybe as a percentage of each project's total cost or based on projected annual revenue. But the point is, this overhead gets added into the estimate along with the direct and indirect project costs to figure out the total cost before profit.
So the final bid price has layers. Direct costs, indirect project costs, company overhead, and then profit on top. It's way more complex than just adding up materials and labor.
Much more complex financial picture, yeah.
Okay, so where do estimators actually get all these numbers? The material costs, the labor rates, the productivity estimates?
Good question. There are basically three main places they look.
Okay.
First, and often the best source, is their own company's historical data, in-house data.
From past jobs.
Exactly. Real costs from similar projects they've done before, using their own crews. This is gold, especially for labor costs, because it reflects their team's actual productivity in their typical working conditions. Experience is the best teacher, right? Past projects give you the most relevant numbers. I remember one time our own data flagged a potential issue with foundation costs because the soil report looked just like a tricky job we did years ago, saved us a potential big hit.
Wow. So having an internal database is a real edge. What if they're doing something totally new, something they don't have history on?
That's where the second source comes in, purchase cost data.
From other companies.
Yeah, especially it's companies that do nothing but compile and publish detailed construction cost info. RS Means is probably the biggest name in North America. They have books, online databases, all sorts of guides for different types of construction. There are others too, like B&I cost books. Some software platforms have integrated data. It's not quite as good as your own specific data, but it gives you solid industry benchmarks. You usually have to adjust it for your specific location and project conditions, though.
So it's like a big industry price list you can use as a starting point. Okay, what's the third source?
The third key source is talking directly to the people involved, subcontractors and suppliers, vendors.
Hitting quotes.
Exactly. Material suppliers, equipment rental companies are usually happy to give you price quotes. Same with subcontractors who might be interested in bidding on parts of the job, like the plumbers or electricians.
So it's a mix. Your own history, industry data, and real-time quotes from the actual suppliers and subs. Makes sense. Okay, with all this complexity, all these factors and numbers, what makes a good estimate? What's the goal?
Well, fundamentally, the goal is simple to state, hard to achieve. Include everything needed for the job and price it all accurately so your estimate matches the final actual cost as closely as possible.
Easy to say.
Right. For contractors, getting it right is absolutely crucial. A bad estimate, one that's too low, means cost overruns they usually have to eat themselves. Hits the bottom line hard. You know, I've seen less experienced estimators sometimes trip up just by not being crystal clear with the owner about exactly what is and isn't included in the price. Leads to arguments later.
So clarity on scope is key too. The source listed a bunch of questions a good estimator asks themselves. It's more than just math, isn't it?
Oh, absolutely. It's about being thorough, meticulous. Like, have I really accounted for and priced everything in the scope? Are my labor and material prices based on current local data? Are the quantities right? Qualities? Even model numbers and colors?
Detail.
Exactly. Do the prices include taxes? Delivery. Will the owner pay for materials stored on site before they're installed? Do the warranties meet the spec? Can we get any discounts for paying suppliers quickly? Have I thought through the risks and allowed for them, maybe with contingency? And, crucially, have I included enough for overhead and a reasonable profit?
Wow, that's quite a checklist. Sounds like a good estimator needs to be part detective, part fortune teller, part super organized accountant.
Something like that. They wear a lot of hats.
The source also mentioned value engineering briefly. What's that about? Is it just finding cheaper stuff?
No, not just cost cutting, although that can be a result. Value engineering, or VE, is more systematic. It's a methodical look at the project's components and systems. The goal is to find ways to reduce the total cost over the project's entire life, not just the upfront construction cost, but without sacrificing essential things like reliability, performance, or the basic design intent. Good estimating in VE, they're not just about the numbers. They're about making smart choices all through the project to get the best overall value for the owner.
So it's about finding smarter, maybe more efficient ways to get the same result, not just defaulting to the cheapest option.
Exactly. It's about balancing upfront cost against long-term costs and benefits. Maybe a slightly more expensive but much more energy-efficient HVAC system. Costs more now but saves a ton on utility bills over 20 years. That's a potential VE opportunity.
Makes sense. And it's best done early.
Oh, definitely. Much more effective during the design phase. When changes are easier and cheaper to make, you're looking for better value, not just lower initial price.
Strategic investment choices, really. Identifying efficiencies without compromising quality.
That's a good way to put it.
Well, this has definitely been a deep dive. Wow. We've gone from why we estimate through the different types, the factors that influence costs, the cost categories themselves, where the numbers come from, all the way to what makes a good estimate.
And hopefully you can see now it's so much more than just a simple guess. It's really a complex projection, influenced by just a ton of factors. You've got to consider scope, materials, location, time, the market, risks,
Yeah.
everything. Understanding those cost buckets and where estimators get their info, it really gives you a deeper appreciation for the whole process, I think.
And for you listening, we hope this delivered that structured overview you were looking for, giving you real insights into construction costs, but hopefully without making your head spin with too much jargon.
So thinking about all those variables we discussed, here's a final thought for you to chew on. What's one factor, maybe something unexpected, that you now realize could seriously impact a project's cost? Even a seemingly simple project. It really highlights how interconnected everything is, doesn't it?
Great question. And hey, if you found this deep dive into estimating insightful, let us know. Tell us what other complex topics you'd like us to unpack in the future.